All right, here's a curvilinear motion question. There's four parts, and here we go. So we have a particle defined by the positions x comma t comma y comma t. That's their position vector, and we're given the derivatives. So we're really given the velocity vector there. So the first question is, find the acceleration at t equals 4. So that's really easy. Uh, this is the position vector. So the acceleration is the derivative. So we're going to take the derivative and we're going to plug in t equals 4. It's a calculator question. So we're going to go right to the calculator. You can see that I have already plugged in these velocities. So all you have to do is calculate the derivatives at 4. So y1, I have the x. So I'll just hit 4. It's 0.433. And the derivative of the second one, y2, at 4 is, nope, that's the first one. So I have to change it over to the second one. Is negative 11.872. So my final answer as a vector is going to be this, 0.433, comma, a negative 11.872. Obviously, you could do this without a calculator because we can take the derivative of anything, but this is a calculator question, so we're going to avoid that. The next is find the y-coordinate of the position. So now we're only looking at y. This becomes basically a linear motion question. We're only looking at y. So the position for linear motion is given by the initial position. So at y, we're given an initial time is 4. So y of 0 would be the initial position of y at t equals 4 plus the net distance, the displacement from 4 to 0. That's just the derivative of its velocity component. So that's just linear motion. So the initial position, which y of 4 is actually this. You're just looking at the y, 5, plus the net change from 4 to where we're trying to get to is 0, which is always the integral of the velocity. So we're looking at the velocity component, the y component. So again, if you just think of it as linear motion, which it is, up and down, that's very familiar. So all we have to do is integrate from 4 to 3. From 4 to 0. So make sure I pick the right graph this time. So the y component from 4 to 0, and it gives me that negative 3.399. And remember, I have to add that to the initial position of 4 or 5. So I'm just going to hit plus 5. And I got 1.600 or 1.601. And that was B. Pretty easy. Part C. On the interval from 0 to 4, what time does the speed of the particle first reach 3.5? So, speed. The speed of the particle is just the square root of the x velocity squared plus the y velocity squared. It's the magnitude of the velocity vector, which that's the definition of the magnitude. So that's all we need to do. We need to figure out where this speed first equals 3.5. So luckily it is a calculator question. What I'm going to do is I'm going to move the 3.5 over to this side. So it's set equal to 0, and then I'm going to calculate the zeros. So I might need the velocities for the next question. So I'm just going to do a whole new equation in y3. So we have the square root of 3t, because I'm squaring it, plus this whole cosine thing. So 3 cosine x squared over 2, and I need to square that whole thing. And then I'm going to subtract the 3.5, so it's set equal to 0. That means the first time that this equals 0 from 0 to 4 will be the answer. And it's right about here. So I'm going to calculate that 0, second calc 0, choose the right graph, y3. Left bound is good here. The right bound, I need to cross the x-axis right here, so I crossed. Enter for the guess, and I get 2.225. So that's the time that it first reaches 3.5. All right, so one left to go. Find the total distance traveled by the particle. So total distance is these are parametric equations. So it's forming some kind of graph. All you need to do is find basically the arc length. So that is always given by the integral square root of these derivatives squared. So it's the arc length of the derivative of these two components squared. We already have the derivatives. So, or you can just call it the velocity components. So it's looking a lot like the last question. So that's how you always find total distance when you're given vector components for curvilinear motion. And remember, these have always got to be the velocities. So we have this pretty much entered in our calculator already, so this is going to be a very simple process. We just have to integrate what I typed in to y3 from 0 to 4. So we'll hit the integral key, 7. I'll change it to that y3. I'll go from 0 to 4. So that was very simple. The answer is negative 0.8175. And that is all. I don't think that's right, though. Hold on a second. Three t squared. Oh, shoot. Big mistake. I just thought that didn't sound right. And you weren't here to tell me I was wrong. Um, whoa. Hopefully you saw that as you're yelling at the screen. I did. I was not careful here. I forgot I put that minus 3.5 in, so that's going to change that answer. Big mistake in this video, but I'm glad I caught it so I didn't have to make a new one. So um, now it should be right. So I got rid of that minus 3.5. That's a horrible mistake. So now I'm going to quickly do this. Now I'm going to take this from 0 to 4. And hopefully I just redeemed myself. The answer is, the distance is 13.182. There we go. Hopefully you enjoyed that one. That was one of my best.